I want to go back to this slide. Screenshot. Okay. So I thought the video was great. I thought it talked about, could you see even historically how bad it was back in the early 1900s? You're like, oh my gosh. And then it got better, but there's still pockets of crap. And sometimes, like when they said there, Mexico City was like the most polluted city, and you could just like see the kind of the green-yellow haze. You know, it's like, dang. So, air pollution. So I could take you to this article, but I won't because I think we saw enough of it. But, I mean, certain cities like shut down based upon, even today, based upon the smog. This is China, I think.
Shanghai.
Shanghai, thank you. So air pollution, by definition, it's something in the air. It could be a gas or solid or liquid, but it's harmful to health, okay? So we're going to see that actually there are natural air pollutants, and then there are pollutants that man puts out. And the term is, and a lot of times it makes it to my your final exam, is anthropogenic pollutants. I think we've talked about this term before, but if you're an anthropologist, you study people. Genic means sort from, so anthropogenic source is from people. Anthropogenic pollutants are from people, okay? But Mother Nature puts them out too. So anything in the air that's harmful to life. So it could be a particulate. So a lot of the harm that's come to people over the years actually is just from particulates. Smoke is an example of particulates. You know, was that fire started naturally, or did Mother Nature start that fire? Well, there you go. The natural sources are anthropogenic sources. Okay, so created by humans versus created by Mother Nature. Okay, so an assortment of air pollutants created by humans. A lot of them come from burning of fossil fuels. That's this one, burning of fossil fuels. Of course, we have other sort of air pollutants. Mother Nature does her fair share too. The volcanoes burping stuff from the inside of the earth puts stuff into the atmosphere that's bad for people's health. Pollen, this time of season, allergies, right? Bad for people's health. Notice these last three over here. Actually, Mother Nature does them, but human influence can play a part. I'm going to actually have a slide talking about the Dust Bowl back in the 1920s, 1930s. And although that dust storms are Mother Nature thing, in that case, it was actually farming that pushed the issue and made it worse. Okay, so we got time. Here's a video in case you haven't seen enough sad things. Anybody in here read? It's a classic. So anthropogenic means made by man. So anthropogenic sources, this slide's all about anthropogenic sources. And most of these come from burning of fossil fuels. Carbon monoxide, lead, although now we're using unleaded gas in our cars. When we burn fossil fuels, we get sulfur dioxide and sulfur trioxide. And actually that helps with, unfortunately, our acid rain issues. Nitric oxide, nitrogen dioxide, again, burning fossil fuels, different types of fossil fuels in different places. There's something called a secondary type of pollutant called photochemical smog, and I think the video we watched mentioned it. A lot of times that haze that you'll see hanging over a city is a photochemical smog. It's a secondary pollutant in that it takes something that was harmless and it reacts with something else, and in the presence of light turns into something, a pollutant. Ozone is also...
Can we pause there for a second?
Sure.
Being harmless and chemically reacting due to light, basically just makes it a physical a visual pollutant instead of an actual harmful substance that would hurt you.
No, hydrocarbons are harmless, but
Okay.
they will react with nitrogen oxides in the line above in the presence of light to create a type of photochemical smog. So,
Okay.
yeah. Ozone, hard to breathe if you have asthma and the ozone is high. Ozone is O3. Remember, there's good ozone, bad ozone. The good ozone is in the stratosphere. That'd be a good test question for your final, because I'm sure we had it on your Unit 1 exam. Good ozone is in the stratosphere. The bad ozone is here in the troposphere. Of course, cars, right? Burn fossil fuels, but they don't put out as much as pollution as they used to, but we're increasing our use of cars. So, I don't know. So right now, I believe they are the major source for putting out carbon dioxide. So we have primary pollutants and secondary pollutants. A type of secondary pollutant was that photochemical smog that we saw a minute ago. Primary pollutant, right out the smokestack, it's bad. Didn't you think that was interesting on the video where it used to be smokestack? Ooh, you know, the dirtier, the better. It's like to be proud that you're putting out all that stuff into the atmosphere. But to me, to be fair, a product of burning fossil fuels is not only carbon dioxide and kind of the ash that's going out, but also water vapor. So some of this actually is condensed water. I won't say all of it, but some of it is. So primary and secondary pollutants. You may have heard of VOCs, VOCs, volatile organic carbons. Volatile means they're like they don't stay in their liquid form. They can, like for instance, gasoline is a volatile organic carbon. Gasoline, if you can smell it, it means it's volatile. It's going into its vapor phase or its gaseous phase. Quite possibly involved with photochemical smog. Oops, sorry. Let's see, do I have a... Okay. So photochemical smog are a set of pollutants, secondary pollutants. So I'm going to show you this other video. I know, see, these slides go fast, but this is so funny. Hope it plays. So one of the things, and you guys are familiar with like asbestos. So asbestos is bad not because it like chemically reacts with anything in our body, but asbestos is bad because of the particle size it is, and it actually can, if it successfully gets to our lung tissue, it can cause havoc just because of the size it is. I guess it has actually the size, and it's crystalline. I think asbestos is crystalline. So my point is, little things actually can be harmful to if they're floating around the air, can be harmful. A lot of times they will size the particulate and to show that it's of concern. So with regard to like suspended solids, dust, that sort of thing, actually it could be stuff suspended in ash that came out of a factory, that sort of thing. One of the things it can do is provide cloud condensation nuclei. Remember several units back, seems like 2 units back maybe, we talked about when clouds form, they form around a little piece of dust, okay? And actually these little, this dust in the air as a pollutant can be a site for cloud and condensation nuclei to form. So, or be cloud condensation nuclei. So here's the deal. You can actually get condensation below 100% relative humidity. And so the word smog actually is kind of fog, which is actually suspended liquid water droplets around crap. That's what smog is. Okay, so that's kind of what's going on. So with regard to pollutants in the United States, carbon monoxide is by far over half. Nitrogen oxides, VOCs, sulfur dioxide, and particulates, kind of in that amount for the primary pollutants. And this slide is kind of showing you what size of particulates, or if they're talking about a size of a particulate, what does that kind of relate to. Where do we get our energy currently, or at the time this was written? Actually, the first two sectors are from burning fossil fuels. Coal and natural gas are both fossil fuels. And then we have nuclear, hydroelectric, and come on. Maybe.
I wonder how much that dam actually powers in our area.
I don't know. That's a good question. It's been there a while.
I mean, probably a lot. You don't see, like, how we don't have power plants other than that, do we?
So your the electricity in Keokuk, where does it come from?
I would assume there,
I don't know. I'd have to
because
track
we
it
don't
down.
have like a power plant other than that hydroelectric plant,
Do.
do we?
Google
I don't wanna
hydroelectric.
Google right now. I Google every class, I don't want to do it today.
Okay, fair enough. But yeah, I think that's interesting. That seems right. The video we watched, did you see a dead fish? I saw a dead fish.
I saw like 4 dead fish.
Did you see like that forest that was basically just sticks there, I think in Germany maybe?
Mhm.
Yeah, acid rain.
When was the last time acid rain was recorded?
It's falling all the time, especially if you're in the New England states or.
Really?
Mm-hmm. Yep. So we call it acid rain, but more broadly, it's just acid deposition, which could be rain or fog or snow. So I'll show you a map. So yeah. And it's a secondary, or it forms from the sulfur-containing oxides that come from burning fossil fuels. So, yep, acid rain can cause pitting and things fall apart when they get acid rained on them. Go figure, right? Now, granted, the acidity in the rain is pretty low, but it's enough to pit things and make things break down. It can be bad to breathe in. And we saw kind of the fish kill and the tree kill. Okay, that's definitely. It says Canada has all of these lifeless lakes because of acid rain. And we're going to see where it's kind of concentrated. So you might be familiar with kind of the pH scale that talks about acidity. So if you look, of course, 7 is neutral, and then anything less than 7 is acidic. Anything more than 7 is what we call basic. Okay, up here. So that's basic. So, but the thing here is this is a logarithmic scale. It's base 10, I believe. So it's 10 base 10 scale. So 1 unit is a factor of 10. And 2 units is a factor of 100. And 3 units is a factor of 1,000. So if there is no acid rain, okay, you figure rainwater is going to be a little bit on the acidic side of neutral. Neutral 7, right? So 5.6 would be acidic. That's normal rain, okay? But I'm going to show you a map here. If we use that as the baseline, you're going to see that we definitely have some locations where rainfall is more acidic. It's a smaller number than 5.6. And you can kind of see the bullseye there. And this bullseye is for 2 reasons, and I think it's on this slide. It's because of the mid-latitude westerlies. So basically we kind of have, if we have any industries over here that are spewing pollutants, and as pollutants have sulfur-containing compounds that can go ahead and fall as sulfuric acid rain, they'll travel this way. The other thing is the Pilgrims landed here. No, really. This is very urbanized, very industrialized. Okay.
Pittsburgh.
Think Pittsburgh. Yeah. So that's kind of those two things.
Yeah, and the ocean breezes probably push that a lot, push that inland a little
Well,
bit.
that's true too. I agree. Like we have this this high pressure out here, the Bermuda high, that kind of brings our cyclones in. Yep. So yeah, it can kind of just shepherd that stuff. Exactly. So the video, I think, talked about one of the solutions is to make your stacks higher. Okay. So this is kind of a creepy sort of look at basically the pollution is just kind of falling down. Must not be any prevailing wind when this picture was taken. Okay, so taller smokestacks. No, I think these are just these are power wires.
No, I mean right there, right in the middle. That looks like a baseball
Yeah,
field.
that does look like a baseball field. How'd you like your kids playing on that?
Seems like Pennsylvania, to be fair.
The video we watched?
No, I
That-
mean, that picture kind of seems like Pennsylvania.
Okay.
Power lines, industry.
But if this is drawn to scale, and if this is drawn to scale and those are power lines, just think how tall that is. Like, oh, really? But making taller smokestacks actually is a good thing, but it's not the end of it. So this is, again, kind of rainfall, rainfall, precipitation. What is the pH? So if, what did we say, 5.6 was what normal rainfall is. So anything lower than 5.6 would be considered more like an acid rain.
5.8, Nevada.
Yeah, that's a little on the basic side of normal.
6.2.
We just need to kind of mix all those together.
6.2 in South Dakota. 6.1 in Nebraska and Kansas.
Mm-hmm.
5.9 in Colorado.
Let's go. So you see that cute little smokestack down there and little puffs of pollution. So wind can disperse for two reasons. One is it kind of spreads it out, but the other one is actually wind can kind of, if it's turbulent at all, kind of take fresh air into your chunk of nasty, basically. Here we have two different wind speeds, and I think we're going to see on the next slide too. Wind speed at 5 meters per second versus 10 meters per second. 10 meters per second disperses it better, right? No kidding. So here we have the faster wind up here and the slower wind down here. So, so anyway, this is a slower wind. You can see where downstream, I guess they wish it was moving faster. So in here, amongst our other discussions, we talked about stable air and unstable air. Okay, so stable air means it doesn't have any tendency to rise. It's a real stable situation if this air is cooler. Okay, if this air is warmer, it wants to rise. If it's warmer than its surrounding, it wants to rise. If it's cooler, it'll just set. Okay, so one type of stable atmosphere actually is something we've talked about before called a temperature inversion. Usually as you go up in elevation, the temperature should get cooler. Okay? But if you kind of flip that, and if you have cool air here and warm air here, that cool air doesn't want to go anywhere. It's flipped. That's a temperature inversion. So here are a couple different ways to get kind of cool air down at the Earth's surface. We talked about actually radiation fog, okay, those cloudless nights. Okay, the Earth can cool down and we leave kind of a cool pocket down here. Subsidence inversions, I have a picture of coming up. Okay, but if you have real stable air and temperature inversion, then your city's not going to breathe, basically. speaking of cities not breathing, this was like about a year ago. I'll show you guys this. And your city can't breathe. Because hopefully, especially because of the urban island heat effect, hopefully your city is nice and warm and toasty and that warm air is unstable. Okay? But if you get a cap on it, then you're in trouble. So this is showing you how do you get the type of temperature inversion we call a subsidence inversion. So basically you get a chunk of air that, remember, as something goes down, it gets smaller. As it gets smaller, it gets warmer. Okay, so that's how you get a lid on your cool air underneath there. Subsidence inversion. So I'm not going to play you this link because I think we saw some of this in the video we watched. But just to kind of recap, in the North America, what we faced in the 1930s, aside from before that, the urban revolution or the industrial revolution. The 1930s was that Dust Bowl. Okay. I guess I should say, after the 1930s and we saw what we were doing with farming and consequences that we could have with not being responsible with our farming, there's some techniques we could do to keep the topsoil there, okay? Improvements were made after that. And this slide is showing you when improvements were made. So for instance, then in the 1950s, the United States said, hey, smokestack people, we are going to gauge the particulates, and then we still gauge the particulates that are being emitted, okay? And we're going to say you can only emit so much. Okay, and I think it's gotten tighter since the 1950s, I hope. By the way they kind of reduce the particulates coming out, there's a couple things. One is they use cleaner fuel, okay? That's a whole other thing. But another is just to kind of put scrubbers that you probably have to kind of change out every once in a while. So that was the 1950s.
The EPA is super strict, by the way. Super strict. It's crazy.
Well, if they keep
there's no way
those.
They haven't have tightened up since.
Yeah. Oh yeah. Yeah.
Because like Roquette gets fined tens of millions of dollars every year.
They just know they're looking at emissions like water emissions and.
Yeah, into the river, into the air, they get fined tens of millions of dollars every year.
They just know it. Yeah. Yeah. So well, I think that it's funny because I feel like sometimes society thinks, we don't have an issue with pollution. Why do we need the EPA? And see, to me, you don't have to look too hard to our not too distant past to think, well, no, we do need them, I think.
The reason that we don't have is because of them.
We don't have because of them?
Pollution. The reason we don't have pollution is because of them.
Yeah, because it's been curbed a lot because of EPA. It's funny, you mentioned some people will actually kind of pay their way out of polluting. So they just know that they're going to have...
is that really that big of a fine for Roquette?
Right. Yeah, they'll just absorb it.
I think last year they paid like $24 million.
They
like, here you go.
So much a day.
They make $1 million a day plus.
Yeah.
That's profit after paying bills.
Yeah. Like
those excursions, they're like, whatever.
Yeah, they're
But I guess at least if they didn't have the EPA, they'd be going just crazy.
Oh my gosh,
It'd be a lot worse.
So Clean Air of 1970, and it was amended in 1990. I'm sure to get stricter. So we've been making progress. So this slide has two dates. The red bar is 1980, and the purple bar is 2007 with regard to these different pollutants. So I've come a long way. And one of the last slides I'm going to show you is in all of these reductions, actually our use of, for instance, automobiles has definitely increased, but we've decreased our emissions, which is exciting. So the last slide, I think, looks like this. So the top two lines, the green line is the GDP, right? Gross domestic product are all we talking about. And that purple line is our vehicles that we're putting on the road. Okay, so look that the vehicles have increased 168% from 1970. Okay, but these other lines are our emissions. Or that line is our energy consumption and population. Yeah, very good. So our energy consumption has gone up 50%-ish. We've
Energy consumption is 41%.
Oh, thanks.
Population is 50.
energy consumption 41%, increased 41%, population 50%. So this isn't too bad.
We're making improvements.
I agree, but I've heard recently about, do we even need the EPA? I swear I heard that. I'm like, what do you mean, do we need the EPA? Duh. So, very good. So this chapter will be due when we come next time, and that does it for tonight. Okay? So, like I said, though, count on, after we go over your test, count on taking a look at climates right quick, kind of what the different climates are, and then we'll do climate change.